So today's lecture I will discuss about frequency spectrum of FM wave. So in order to draw the frequency spectrum, first you have to look into some equations related to this. So FM, we know that FM is the sine of sine only, FM expression, you know the general expression for FM. It is there, it is a sine of sine. We see sine of omega ct plus beta sine omega mt. It's a sine of sine. So to solve this sine of sine term, we need a function. It is called a Bessel function. Okay, we need a function. It is called a Bessel function. So this is our equation: sine of omega ct plus mf sine omega mt. This mf or beta, you can put either mf or beta sine omega m into t. So the solution to this equation will be, we are using Bessel function. For the solution of this equation, we need the help of Bessel function. This is the Bessel function solution. V equal to a j0 mf or beta, anything. You can put beta or mf. A j0 mf sin omega ct plus j1 mf sin omega c plus omega m in t minus omega sin omega c minus omega m in t plus j2 mf sin omega c plus 2 omega m in t plus sin omega c minus 2 omega m in t plus j3 mf sin omega c plus 3 omega m in t minus sin omega c minus 3 omega m in t plus like that, etc. It is going. So jn of beta or jn of mf is the solution of the equation of the form. This is the equation. This is the general standard form of equation solution for this. mf of mf square d square y by dmf square into mf into dy by dmf into mf square minus n square into y equal to 0. So this solution is the formula we obtained from the Bessel function. This is actually the Bessel function. Jn of beta equal to mf by 2 the whole raised to n into 1 by n factorial minus mf by 2 the whole square 1 factorial into n plus 1 factorial plus mf by 2 the whole raised to 4 by 2 factorial into n minus 2 factorial, etc. It is going like that. So in order to evaluate the value of given pair of sidebands, it is necessary to know the corresponding Bessel function. See, so this is our equation. This equation can be solved with the help of Bessel function. Okay, this is the Bessel function equation. This is the standard form, and Bessel function can be obtained for this kind of things with this. And by doing some mathematical calculation, we obtain this general solution. This is this equation. Okay, sine of sine. This equation is solved with the help of Bessel function, and it is looked like this. Okay, look at here. Here we have a into j0 beta sin omega ct plus j1 beta or mf, j1 mf sin omega c, like that it is going. Okay, so here this component is called center frequency or carrier component, and all other components are we call it as sideband components. See, J1 have two components, J2 have upper and lower. This is upper component, this is lower component. This is for J2, this is upper component, this is lower component, like that. These are the combination of different sidebands and a carrier. So this is the mathematical expression for frequency spectrum, and how it is drawing. Let's look into it. This is the actual spectrum. See, this is the spectrum of FM. See, this is center frequency FC. So I told J0, this amplitude is represented by that coefficient. Okay, in this amplitude J0 of beta or J0 of mf represents the amplitude. So this is J0 of mf, is the carrier amplitude. Next is FC plus fm and FC minus fm, FC plus 2fm, FC minus 2fm, like that it is going components. And the amplitude is J1 of mf, J1 of mf, J2 of mf, J2 of mf, like that. So how these components we are getting? From here only. So here this is the carrier. Or FC plus fm, upper component, FC minus fm, lower component, both are having amplitude J1 of mf. That is this. FC plus fm upper component, FC minus fm lower component, both have same amplitude J1 of mf. Clear? That's This is from this equation only. Now J2 of M of sin Fc plus 2 Fm and sin Fc minus 2 Fm, and amplitude is J2 of Mf. How it is writing? See, J2 of Mf, Fc plus 2 Fm, we have J2 of Mf. Similarly, Fc minus 2 Fm, we have J2 of Mf. Like that it is going. So actually infinite number of sidebands are there. Why? Because the sine of this function, if you solve with the help of Bessel function, you will get infinite number of sidebands. It's a carrier and infinite number of sidebands. So the question is, how you will get this coefficient value? You need this coefficient value, then only you can draw this amplitude. Anyhow, you have to give an amplitude. This is having this much amplitude, this is having this much, this amplitude is decreasing, but you should know this component value, then only you will be able to know it is decreasing or increasing. That means you have to know the amplitude value. So this will be normally you will get from a table, and that table will be normally given in the question paper for different Bessel function coefficient values. Okay, and no problem about that. Those information will be available in table form. They will provide in the question paper. So the spectrum is in the form, suppose carrier voltage is 1 volt and beta or MF is 1, and it is given that J0 first component, J0 is 0.77, J1 is 0.44, J2 0.11, J3 0.02, like that. Then it is known that as J0 is having maximum amplitude, J1, J2, J3 it is decreasing. Okay, so this is the general spectrum. So what is the bandwidth? So actually it is going from upper side and lower side, it is going like this. So what is the bandwidth? Bandwidth is nothing but 2 times F. See, upper side band minus lower side band, like that you have to take. But here infinite number of upper side band and infinite number of lower side band. But we have a common thing, something is repeating. This duration is same as that of this duration. This duration is same as this. This duration is same as this. This duration is same as this. Why? Because it is Fc plus Fm, Fc minus Fm, Fc plus 2 Fm, Fc minus 2 Fm, Fc plus 3 Fm, Fc minus 3 Fm. Next Fc plus 4 Fm, Fc minus 4 Fm, Fc plus 5 Fm, Fc minus 5 Fm, etc. It is going like that. So how to find out the bandwidth? Take a single component bandwidth, then multiply it by n times. Simple. So the bandwidth of this first component, Fc plus Fm and Fc minus Fm, if you take the bandwidth, how to take bandwidth? Upper frequency minus lower frequency, you will get 2 Fm. So multiply that 2 Fm with the n number of components. See, 2 Fm multiplied by n number of components, you will get the total bandwidth of Fm. So ideally bandwidth of Fm is infinite. Why? Because infinite number of components are multiplying with this frequency, so definitely bandwidth is also going to infinity. So n is the number of sidebands. Theoretically there are infinite number of sidebands, that is n is equal to infinite. So bandwidth of Fm is infinite in theoretical. But we always want a very limited bandwidth. That means signal bandwidth should be very less, channel bandwidth should be very high. That is always our aim in communication. It is like that. That means signal bandwidth less means we are able to send more number of signals through the given channel. Channel bandwidth should be high, signal bandwidth should be low. So but here the bandwidth of the FM is very high, infinite. But if we are neglecting the sidebands of lower amplitude, we can approximate the bandwidth of FM. Okay, see as it is going infinite, see the amplitude is going very down. No, amplitude is decreasing very sharply. Why? Because here it is amplitude of 0.77, here it is 0.02. Like that it is approaching to 0. As the component reaches infinite, the amplitude of the component becomes 0. This is the concept here. So as we goes on infinite times, upper sidebands, n number of upper sidebands we have. No, this upper sideband have very limited band, very less amplitude, so we can neglect that. So that's why it is written. But if we are neglecting the sidebands with the lower amplitudes, we can approximate the bandwidth of FM as 2 times beta plus 1 into FM. So this is the general equation for bandwidth for FM. That is 2 times beta plus 1 into FM. Beta or MF, it is nothing but modulation index, and its value is delta F by FM, where beta plus 1 or MF plus 1 significant sideband. That means beta plus 1 upper and lower sideband have the sufficient power. Okay, above beta plus 1 sideband have a negligible amount of power only, so we can neglect that. Maximum power we will be, that is 99.9% of power we will be getting from beta plus 1 upper sideband. അതായത് ഇതിനകത്ത് നിങ്ങൾ ബീറ്റ പ്ലസ് 1 സൈഡ് ബാൻഡ് എടുക്കുമ്പോൾ തന്നെ നിങ്ങൾക്ക് കിട്ടേണ്ട മുഴുവൻ 99% പവറും അവിടെ തന്നെ കിട്ടും. ബാക്കി 1% പവർ എന്ന് പറയുന്നത് ഇൻഫിനിറ്റ് ടൈംസിൽ കിടക്കുകയാണ്. അതുകൊണ്ട് ആ ചെറിയൊരു പവറിനെ നമുക്ക് കളഞ്ഞാലും കുഴപ്പമില്ല. സോ വി നെഗ്ലക്റ്റിംഗ് ദാറ്റ് ഇൻഫിനിറ്റ് നമ്പർ ഓഫ് സൈഡ് ബാൻഡ്സ് ആൻഡ് വി ആർ കൺക്ലൂഡിങ് ദാറ്റ് ബാൻഡ് വിത്ത് എ കൺഫൈൻഡ് ഫോം ദാറ്റ് ബാൻഡ്വിഡ്ത്ത് ഈസ് ഈക്വൽ ടു 2 times beta plus 1 into Fm or MF plus 1 into Fm. So and beta is nothing but modulation index, it is delta F by Fm. So bandwidth is, we can represent as, instead of beta you can represent bandwidth equal to 2 into delta F by Fm plus 1 into Fm, or you cross multiply this, you will get 2 into delta F plus Fm. Both are important equation of bandwidth. These important equations are very important. Okay, so this is about bandwidth of Fm. Next is average power, that we will discuss in next lecture.